alkanes are not very reactive. They don't have a functional group, so they tend to be quite stable molecules. There are, however, three processes they undergo. There is combustion, which we've already met. There is cracking, again we've already met that. And the third type of reaction is forming haloalkanes. So we call this halogenation, adding a halogen in. Now remember, the halogens are the group 17 elements. That's your fluorine, chlorine, bromine and iodine. Okay? The halogens are often represented with an X or X2 for the element, X minus for the halide ion, chloride, fluoride and so on. Okay, so molecules of halogens can add across a single bond to convert alkanes into haloalkanes and a hydrogen halide, but it's not a reaction that happens readily. That means it requires a catalyst and it requires time. Now the catalyst required for this reaction is ultraviolet light, so we need to sit this reaction in sunlight or some other source of UV light. You put this reaction in a dark cupboard and nothing's going to happen. So for example, if we take an alkane and we react it with bromine, Br2, with ultraviolet light, bromine, you may recall, is orange in colour, or bromine water is orange in colour. Bromine, the element, the liquid, is a red-brown colour. It's quite a bit darker than bromine water. But bromine water is orange. When it reacts with an alkane, then that orange colour decolorizes, it fades, and it will eventually go colourless. It may go yellow first, but it will eventually become colourless. And that's where one halogen atom is being added into the structure of the alkane. So you can see in the diagrams below where you've got ethane, and we've represented the carbons with the green and the hydrogen with 6 white balls. One of those hydrogen atoms is removed and it is replaced with a halogen. Okay? So we call this a substitution reaction. It's a substitution reaction because one hydrogen has been removed from the alkane and it has been substituted with a halogen atom.